enjoyed the TEQnation so far? Yeah. Yeah, I would say that the food was really great. I gave 5 stars. I hope the winner of the ratings would not be the food, of course, but I really liked especially the beef one. So I think it's the time, or maybe we can wait 1 more minute to see if any other people wants to join or not. I'll see some people are joining. So, okay, I will start.
Don't worry, I'm seeing you.
Huh?
Don't worry, I'm seeing you.
I don't know.
Okay.
Your microphone is working?
Yep.
Okay.
Can you hear me?
Okay, awesome.
Also, I can hear myself, so.
So, welcome to this talk, and I hope all of you have enjoyed the TEQnation so far. So we have secure software ecosystem. I want to start with some sort of flashback to a few things on the news that we've seen before, but I want to all of us remember those things.
Yeah. SolarWinds got compromised in 2020.
And Log4Shell disaster, you all remember it, right? In 2021.
A Spring4Shell vulnerability also got discovered in 2022.
And the beautiful XZ Backdoor, it was just few weeks ago. We are living in an unsecure world, and all the softwares and applications that we have are probable to get exploited. We could be the next target. Are we ready?
Probably not. Because still 30% of Log4j downloads are vulnerable to Log4Shell based on Sonatype report, and it's 2 years after the disaster.
It's unbelievable. But why we are here? He's the security engineer, and I am the developer. So we're going to talk about this topic from 2 different points of view. But who we are?
Yeah, I'm Ali, security engineer with over 10 years experience in the different industry and sector. And right now, I'm principal product security engineer at Scoutbee. It's a company in Berlin. And also, I'm leading OWASP DevSecOps project guideline. And that's it.
And I'm Soroosh, just another developer in the office for almost 10, 15 years. But now they call me architect in Rabobank. And I'm kind of a researcher in the supply chain security. So I'm going to share my experience with Ali regarding this topic to you. If you want to reach out to us, you can use our social media handles here. Ali.
Yeah, classic attacks. As a developer, you may know most common cybersecurity attack, the classic attacks, and may you know how we can protect our application, more or less, how we can protect them for this type of classic attack. For example, let's check RCE, or remote code execution. So you include a functionality or function in your code that can run system command as part of your code. For example, you want to create a application, web application that people can put the IP address and ping that IP address. But if you didn't sanitize user inputs correctly, it could be vulnerable to remote command execution. And this is classic type of attacks that we have, because you have to take care about your code, and if you do some SAST, static application security test, sorry, and then you can make sure that your code is safe. But there is another type. Here we have OWASP Top 10, two versions of OWASP Top 10, 2017 and 2021, and you can see that how it's transferred the security, high security risk that we have. For example, some of them merge or some new items add to the list, for example, insecure design. And we are pretty sure that supply chain attack will be one of the items in the next release. And what is supply chain attack? While we are taking care about classic attack, there is another type of underestimated attacks, which is called supply chain attack. And right now, supply chain attack targeted the gap to the trust between our code base and dependency that we are using. And if we back to the RCE, so you can see that Log4Shell was vulnerable to RCE. And if we are adding that code in our code base, even our code base is not vulnerable, maybe that could be because of RCE. And here we have different types of supply chain attack, which is the most important one is dependency confusion, that we will talk about that.
Yeah. So dependency confusion, it's really nice. It was COVID time, and a guy who was a bit bored, and he started to thinking about the things that we do as a developer. So he tried something, and he actually succeeded in hacking, I don't know, Google, Meta, PayPal, and all those big names by a really simple trick. I've put a link here. You can read it. A 3-year-old kid can understand the way that he hacked those companies. Really simple. I will explain it with one example here for you. So just imagine you have a shared component in your company. Let's call it my company UI component. More or less, all the companies that have the front end, they have such a library, right? You developed it in your company, and you pushed it into a private repository, like GitLab, GitHub, I don't know, the Nexus repository, something like that. You pushed it there, and when you want to download it, you think that you will download it from the private repository. One day, a smart hacker will find out that you have such a library or artifact in your company. He finds or she finds the name of that library, right? And the hacker tries to push that library with the same name under one of the public repositories. So for example, on the NPM. The difference that you can see here is the version, right? So on the private repository, the version is 1.2.5, but on the public one, it's 6.6.6. And as a lazy developer, I will put latest here because I want to be always up to date, right? And when I run the npm install, what would happen? The package manager get confused which one I should download. It says latest, and I will download the latest one. So I'm inviting the malicious code to my environment with my own hand, and I have no clue what would happen the next. They can run anything on my machine, on my CI/CD, on my production environment. And this is what we call it dependency confusion, as one of the most trending supply chain attack. It's really, really important. And I can tell you, many of the companies that you're working for them, they are vulnerable to these type of attacks. Because we're a developer, right? We are always using the ranges and latest and those things in our package.json, or not only in the package.json, in the other things that we have in the Maven and PyPy, those things. I have a question from you. How we can download the whole internet with one command? Yes, I can hear it. npm install. I love it, right? So we all know, right? It's even heavier than the black hole, and you can see there is no end for it, right? So we're downloading the whole internet in our machine. And what's the relation with it? I want to do one npm install. I'm just creating a really, really, really basic and tiny app here. I'm just creating an application, and I install Express. So you know what is Express? It's one of the most famous frameworks for the Node.js applications that you can actually build some API on top of it, right? It's pretty simple. One of the most used libraries. It's really nice, right? And you can see that in my package.json, I only have this Express as a dependency. Nothing more. Only one dependency. But we all know that the Express.js also have some dependencies. So I want to see how many dependencies I'm actually importing into my application, right? So there are many ways to create the dependency tree, right? I want to use the simplest one, the npm ls. I'm not sure if it's visible or not, but you will see only one line on the depth 0, right? I want to increase the depth to see how many subdependencies I have in my tiny application. And for the depth 1 is 32 dependency. So can you guess if I increase the depth to 2, how many dependency I will see here? Just try to guess a number. 364? Close. Yeah. 65. And it's actually deduplicated because, yeah, some of the packages are common. Can you believe it? I only imported one dependency, and I ended up having 65 dependency. And as Ali also mentioned, if one of those dependencies has a vulnerability, my application will also have that vulnerability. So that's the supply chain attack, and we need to be really careful about this. So I have a really good slide here, right? But you can also download the slide later. What we should do to prevent or minimize the risk of supply chain attack. 3 categories: must, good, and nice. And for the must, reserve namespace, scope, and prefix. What it is? If in your company you're building artifact, you're building library, or whatever, for sure you're doing that, please sit together and agree on a naming convention and try to stick to a naming convention. And before pushing the first artifact, reserve it on the public repositories. If it's on the NPM, just reserve it, reserve the scope. If it's on NuGet, reserve the namespace, prefix, and the other things like Docker, etc. Version pinning, what we don't do, right? What we should do. Do not use caret or tilde or those things or latest. Try to put a specific version in the packages on your POM or whatever, right? Package integrity check is also important. You can use a lot of tools to do that. You can also use the package lock to help you for that one. You can also use something similar for the Maven. It also has a plugin that provides same capability. And the last but not least, immutable version. This is what I've seen a lot in the companies. Oh, we just forgot to remove a comment. Let's just put the same version on the new release because we didn't change anything. We don't want to share release log, right? Let's replace the previous one, right? Those things are really dangerous. It's a must. Try to release the version in an immutable way, right? Do not replace or overwrite the old versions because nothing has been changed. I just removed a space or comment. Good. Using SCA tool. We will explain a bit later. Official repositories. Do not copy and paste the repositories from the Stack Overflow or ChatGPT or whatever. Try to stick to the public repositories or the official ones. Keep dependencies up to date. For God's sake. We all have a lot of libraries that are super old. And we also showed you the log4j, still the people are downloading the vulnerable version. Come on. They're downloading old version. 2 years old version, which is still vulnerable. And we know how important it is. And if you have a company that has a lot of money and a lot of users, so maybe it's a bit hard to encourage everyone to do the package integrity check or version pinning or whatever, or use the official repositories, you can buy a software called Dependency Firewall. You can search on the internet what it is. There are very good tools that can help you to not downloading the packages that are not official or maybe they're not really safe to download. And last but not least, clean up unused library. We used to import the libraries by pressing the Alt-Enter, Control-Enter, Command-Enter in the IntelliJ or other IDEs, and it was really nice, right? But if we are not using any library, let's remove them, right? It would help us because we are not inviting a lot of dependency and sub-dependencies in our application that we don't know if they are vulnerable or not. Yeah, you can take a look at the links here in the read more to understand a bit how to do those things. Yeah, Ali.
Yeah. Application development journey already changed. In the traditional approach of software development, security always was at the end. That was the starting our friendship that Soroosh asked me for signing a go live paper in the company as a security guy, and I told him that, okay, we didn't did any security check, and he said, okay, it's 5 hours before go live, so if you want, you can do security checks, and I got confused that how I can do that.
He was a good security guy, by the way.
So, as a security guy, if you are enough lucky, you could test application while it was in the staging environment or pre-production or any name that we had. Or if you are unlucky security tester, you have to test the application while it was up and running in the production. And it was because of a lot of vulnerability that we found in the production environment. A lot of data leakage, a lot of critical incident that we deal with that. But detect early and pay less. This is the main approach that we moved to the current stage. And we are saying that actually researchers says that how we can manage time and money with catching security issues as fast as possible and as much as early in the pipeline. For example, if we remediate one security concern in coding, it would be cost 6 times less than production environment. And this is the main reason that in the modern approach, we should try to shift security tests to the left. Yeah, and this is the modern approach. Right now, by using shift left, we say that we have to invite security and involve security from design phase. We say that security should be baked in the product. So product should be secure by design. So we need security at the design and also threat modeling, which is help us to understanding better the product and threat around that and try to protect the product based on that. And also in the development phase, we have different checks that we can do for improving our code from security perspective. For example, using 4 eyes principle review to make sure that code is safe. Also doing secret scanning. A lot of bug bounty report on HackerOne or BugCrowd shows that credential leakage or hard-coded credential in the public repositories is cause of companies pay a lot of bounties to the bug hunter. So, and also, for example, so if we can find any hard-coded credential by doing secret scanning, so it would be help us to don't push that credential into the production environment. And also SAST, which is Static Application Security Test, which review our code bases from security perspective and make sure that, okay, do we have any user input sanitization or not, or this is safe function that we are using or not. And also we have SCA, or software composition analysis, that we will talk about it later. And for example, EOC scanning, which is infrastructure as a code scanning. Misconfiguration is the first cause of security vulnerability in the cloud-native applications. So taking care about EOC scanning and infrastructure as a code. So Terraform, any Helm chart, and any Kubernetes definition that we have is also important. So we have to think about that. And also container image scanning. Scan the container from different angle. In the security, we say that security is something that we have to think about it layer by layer. It's not one layer of security that we can put on the top of a product and say, okay, the product is secure. And also in the deployment phase, when application is deployed into the staging environment, so we have the first version of application that we can communicate and interact with that. So it's a good time for having DAST, or dynamic application security test, and doing some load tests to make sure that application from availability perspective is also ready for production. And the important note here is, if just one note here, that if you like to know more about these checks and type of security topics that we have here, you can check this link and go to the OWASP DevSecOps guideline and know more about them, and also see the tools and solution that you can use. And also, the more important note here is that phase can cover, but cannot replace by each other. For example, we cannot say, okay, we have SAST, so we don't need to have a software composition analysis, because they are targeting and searching for find vulnerabilities in a different angle. And yeah, still, while we are focusing on shift security to the left, still the right side is the most potential attack surface that we have. A lot of posts in LinkedIn, Twitter, and everywhere. Right now, shifting security to left, or DevSecOps, is a buzzword, I can say. And a lot of companies provide products that can focusing on left side, but still the most important part is a production environment that we have to think about that from a different perspective. For example, we need to set up firewall, do penetration test, maybe bug bounty. If your application if you did more or less 2 or 3 times penetration test, so it's not bad for going for vulnerability disclosure program or VDP or penetration or bug bounty, which involve a lot of hunters to find vulnerability in your application. And also the important one is continuous monitoring that helps you to have a more visibility and observability from security perspective on your code base.
Thank you. Continuous dependency monitoring production. So the security guy asked me to do that, so I did the research, right? So what we should do for the continuous dependency monitoring. So it's about dependencies. So I need to have a list of dependencies. So I already know that I can do that npm ls thingy to create a dependency tree, but it's not a proper format. So I need a proper format to list down all the dependencies that I have. So we call that format SBOM. I will explain in 1 minute later. And after I have the SBOM, I need to do the continuous monitoring on those dependencies to see if there is any vulnerability discovered for those dependencies or not. But how? Bear with me. So first, software bill of materials, what it is. It's a format that I can put the application identifier, application metadata, so a lot of information that kind of related to that application, like business criticality. Is it a really important application for my business? So there are also some format for it. In some companies, they call it AIC rating or CIA rating, confidentiality, integrity, and availability. Or I can also put a list of dependencies, libraries, and the vulnerabilities that we already know those dependencies has. Because some of the dependencies, they have a known vulnerability. They are not that much important, but we need to document them somewhere. And those dependencies, they also have some licenses, right? It's good to also have those things in one place. And we should also know who are the suppliers, who supplied that artifact to us, right? It's important for some companies, for big organizations, because of the sanctions and everything. And authors. Who created this application? Who is owner of this application? Who is owner of this dependency, right? We will put all these things in one file, and we call it SBOM. And there are 2 different formats for this file, but it doesn't really matter. They're convertible. And this is one example for this SBOM. You can see it. So, I can this one. So you will see it's a JSON format. We have the components. There are some details of that components. For example, this one is Apache Tomcat. The version, even the URL that we downloaded this artifact are there, right? How this SBOM will help us in practice. I want to, again, tell the story of the Log4j. Who has experienced the Log4j disaster? Okay, so I want to tell a story that is familiar to many of you. So it was in the December, right? Everybody was preparing to go for a vacation. They had their own plan. And on a Friday night, on all the website, there was a really big title. Log4Shell, CVSS score 10 out of 10, critical. Everyone in the big companies and even in the small companies were freaked out. Something happened with Minecraft, but it can also impact us. What the hell is this? Are we affected? Which application is affected? Who we need to contact? How to fix it? How to detect it? And everyone was freaked out and they were asking this question over and over and over. Do you remember it? And it took, for some companies, more than 6 months to find answer for those questions, right? But what if we had SBOM? Just imagine that we had the SBOM, and as I said, there is a link between the SBOM and the application. Just imagine that we collected all the SBOM for all the applications that we had in the company, right? And maybe we built something in-house, or maybe we were using a standard product, and we were doing the continuous monitoring, because there are some open source databases that actually report the vulnerabilities for the dependencies and components, right? And we were doing the continuous monitoring every hour, every day to see if those dependencies are still safe or not, right? And once the 0-day alert happened, or the 0-day happens, right? Then we could ask our question from our tool, right? Or query the result of those questions in our tool. Which application is affected? We have all the SBOMs, right? We can just search for the dependency. Or some of those tools, the standard applications or the good ones that we have in the market, they can also search based on the CVE. So you can say, which applications from the list of SBOMs that I have in the database are vulnerable to that Log4Shell, for example. Okay, we have the list of them. Which one needs to be fixed immediately? I want to send some consultants, some experts to fix those applications, right? Which one? So I can search based on the business criticality because I have it in the SBOM as a metadata. Who to contact? Yeah, I have the contact. I have the email address. I have mobile numbers. I don't know, whatever that is the preferred way in my company, right? I can just send them an email. I can call them, right? Even if it's in the, I don't know, Friday, but it's critical, I don't need to worry to find a person that I don't know who he is. I have all the information in the SBOM. And when they fixed it, right, I can have a real-time monitoring on it. Because when they're deploying, they're also submitting new SBOM in that application, and I'm also doing the continuous monitoring, so I will have a real-time insight, real-time overview on number of the applications that are still vulnerable. Okay. Are you convinced or not? It depends. The answer is it depends on how hard it is, right? So I will explain how easy it is. So how to generate SBOM? We can generate SBOM on a different phase based on different input. So we can generate based on the source code, container image, the artifact, jar file, var file, and also in the runtime environment. How? So before how, where? So look at this picture, right? So it's a journey of SBOM in our pipeline. It's not a complete pipeline. I just put one part of it. So you will see that I have the code. There are some dependencies, right? And I build, and I can generate the SBOM after the build. I can also do it before the build, right? But let's generate the SBOM. And how? There is a tool called CDXGen from OWASP. It's super easy to use, easy to download, open source, free to use. Just run this command in the root directory of your code. CDXGen-O, and just write the name, a file name. And that's it. It will detect your language, your framework, and it will list down everything, right? And you have your SBOM, you can use it. Easy. Or if you are a Java developer and you're using Maven, you can just add this dependency to your POM. It's super easy. And you can actually run a Go and you have the SBOM in your pipeline. Super easy. Or if you're using the latest version of a Spring Boot, you can just call this API. If you want to know more about how to do those things, there is a really interesting talk from Thomas. So in the DevOps UK a week ago, he had a talk about the SBOM in Java. You can watch it. I put the link here. I really recommend that one. If you have a Docker image, it's also easy. There is a library called Sift. You just run one command, and you have SBOM for your Docker image. It's super, super easy. As you can see, I put the link, right? I put the example, a screenshot here. You can do it as easy as I'm showing you here. And I'm done. I generated the SBOM. Here you are.
Yeah.
What should I do next? The security guy.
Now we want to talk about software composition analysis, or SCA, or maybe they call it third-party scanning or things like that. And as we can see here, we generate SBOM. And also, Soroosh mentioned that in the SBOM format, we have vulnerabilities. But if we want to deep dive in the generated SBOM from security perspective, we can engage software composition analysis phase and do it deeply. And SCA help us to find vulnerabilities in the generated SBOM or in the third-party code that we are using. Also, it provides the list of license of third-party components that we are using. It's really helpful for organization or commercial use that you know which licenses that you are using. And yeah, for example, how we can do that. This is a tool called DevScan, released by OWASP as an open source solution. And you can easily set up it as a part of your pipeline. And DevScan under the hood using CDXGen for generating SBOM and run vulnerability scan on top of it based on vulnerability databases, which is connected with them, and generate a result like this. For example, here, as you can see, on the top, I just input one SBOM JSON file and just mention the technology is Java that we are using. And you can see that it lists all of the vulnerabilities related to this code base and components that we are using. Also, it can generate a list of licenses. You can see that which licenses is in the way that you want, that you can use as a commercial solution or not. This is really straightforward.
By the way, Java is safe. You mentioned Java. I'm a Java fan.
And here, as we can see, more solution as an open source and free, and also commercial solution that you can use. And also, you can check this link for getting more tool and technology that you can use. And OK, we generated a SBOM. And also, we did SCA as a software composition analysis. So we need more visibility on that. And this is the phase that we want to talk about that right now. And this is, OK, we have to do continuous monitoring on top of the SBOM repository that we have. And here we have one tool, which is also from OWASP. And this is dependency track that provide you a dashboard, a web-based dashboard that you can create one project, many projects as you want, and also import all of this generated SBOM and all of the dependency scanning that you did. And it will show you that result that you have in the JSON file in the fancy and nice dashboard. For example, number of components, services, dependency graph, audit vulnerability. Also, you can define some policy and make sure that your code didn't have any policy violation. And there is other competitor of dependency track. Actually, for open source, we couldn't find more, so we just put dependency track. And for commercial one, you can use different solutions that you may know about them.
OK, thank you. I tried to follow what you said. Shift left, right? I implemented all those fancy tools. SCA, SAS, continuous monitoring, container scanning, IAC, I don't know. I put firewall, a really expensive one, right? Continuous monitoring, login monitoring. And I kind of feel safe now, right? I can sleep easily at night, right? Because I have all those tools. And I did the shift left and shield right. So I should be really safe now, right? You're the security guy.
Yeah. I have answer for you by a quote from Bruce Schneider, who says that if you think technology can solve your security problems, then you don't understand the problems and you don't understand the technology.
OK.
So, yeah, tool and technology is one aspect of modern approach of have a secure application. And we have to consider people and process and governance as well. And this is 3 pillars of DevSecOps that we say DevSecOps right now.
Did you hear what he said? What he said? He said DevSecOps. Come on. I don't want to do that. A few years ago, almost 10 years ago, we were doing our backend, right? It was really nice. We were doing our code, delivering our features. It was very nice, right? And then they started asking us to do some extra stuff, and they called us full stack developer, right? It was still nice, except the part that we need to learn JavaScript frameworks every day, right? That was, you have them there, right? You understand what I'm saying, right? Those days were really good old days. And eventually, they asked us to also do more stuff, right? They didn't ask us, actually, and they told us to do that, right? And they told us DevOps engineer. And I'm still figuring out, and it's hard for me to digest, what are my roles and responsibilities as a DevOps engineer. And this guy is telling me that you should do DevSecOps. I don't buy it. I want to exit this room, right? I want to go out. I don't want to be the developer anymore, right?
Okay.
What is this?
OK, bear with me. I will explain to you that, yeah, this is the team story. In the traditional way of application deployment, development, we had ops team, which was a separate team, security, which was also separate and just using as a someone that as a gatekeeper that should be signed the go live paper. And also we had team that they call it agile development team and product manager, QA, and developers. By the advent of DevSecOps, we shift to this picture and these teams. Actually, ops also involved as a one member or member of agile development team, and they call it DevOps team. So by moving from DevOps to DevSecOps, security also be in charge as a part of the agile development team. So let me clear this, that in many companies, since I'm DevSecOps engineer, many companies thought that if they hire DevSecOps engineer, they hire DevOps engineer plus security engineer, so they can save some money from HR perspective. But to be honest, DevSecOps engineer is a security engineer that can play as a part of the DevSecOps agile team. And yeah, traditionally approach was developer was responsible for fast delivery, security was in charge for security, and operation was responsible for stability. But DevSecOps aim this to fill the gap between development, security, and operation. So the goal of DevSecOps is destroy the silos to achieve the goal of delivering secure and stable software quickly.
Looks promising, but it really depends how the organization will translate it, right?
Yeah.
Hopefully, not like what they did with DevOps. Thank you, Ali. We promised the boring part, regulations, right? Who heard of DORA? Yes, I see some people that work in finance, right? So the regulations, even if we like them or not, they're incoming, right? So for the US companies, there have been a lot of regulations there for almost 10 years. But nowadays, there are some new regulations coming for the European companies. So one of them is CRA, and another one is the DORA. But the DORA is for the financial sector, like insurance. I think we have some people from NN here, and other banking employees here, that IBM AMRO, ING, and also the Rabobank. So you might see this CRA also, and also the financial sector one, the DORA, or maybe you already have a lot of meetings about it. So I want to make it a bit more clear for you what needs to be done. So, or when it needs to be done. So what needs to be done from these, for this talk is you need to implement SBOM. So that's the point. You need to implement SBOM for your application in your development lifecycle. You should actually implement and collect all the SBOMs in a proper way. But when you need to do that? For the CRA, a few weeks ago, the regulation got approved. And it will enter into effect from Q2 2024. And you're going to have 20 till 24 months to implement those things. There are also some other exceptions that maybe some of them will have a longer deadline, but you will have around 2 years to implement those things. So I think it's good to start to explore the opportunities first, right? And then implement the solutions. Because as I also mentioned, and also Ali also mentioned, there are a lot of value in actually having those SBOMs. I put the link. You can also take a look at this one. So the CRA really explained well here with all the details, all the things that need to be included in the SBOM that actually the regulations ask you to do. DORA. It's not related to SBOM directly, but indirectly, you need to implement SBOM. Why? So DORA is more about how your application works from the stability point of view, how you're observing your application, the metrics, etc. And it's really focused on the failure rate and those things. So one of the items in the DORA is you need to have proper processes and solutions in place to be able to fix your application as soon as it's possible. So for some vulnerability or maybe for some other reasons that your application has a problem. And for that one, we already went through the Log4Shell story, right? So by implementing SBOM, you can achieve that goal, right? So it would be good to also keep in mind that for the DORA, you can also have the SBOM, and it's also really valuable. I think the deadline for the DORA is Q1 2025. So we only have 3 quarters maybe. And standards. So there is an ISO. You can take a look at that. This ISO has some items for the SBOM, so to supplier relations and those things. And we have also 2 other standards, the Cyclone and SPDX, that are actually the format of SBOM. As I said, it doesn't really matter that much. They have some differences, but they're convertible, right? And both of them are open source, and you can also contribute to those formats. There is also a framework called SLSA, which I really like it, because it tried to create a picture about the maturity of an organization, about the supply chain security, right? So there are some baby steps that you can take, and by just taking those baby steps, you can make your organization a bit more mature and become more secure in each level against the supply chain attacks. So take a look at the SLSA. I really like it, and there are a lot of nice explanation, recommendation, and things like that. I also put some links here, and in all the slides, there were some read mores. I don't know if you saw it or not. Just take a look and deep dive more in each topic that you're interested in. That's it. Thanks for your attention. Please rate this talk on the NLJOG app, and if you have any question, feel free to ask. Thank you. Thank you.